Welcome to another lesson on the derivation. Today we're looking at relationship between linear and angular motion. So look at the parameter, relation between distance, velocity, and acceleration. In terms of linear, distance is represented in s, velocity is represented in v, acceleration is represented in a. While in angular, it is psi w, which is omega, and a. They are both the same a. Now, before we derive the relationship between the linear and the angular, let us look what is linear. Let's look at the parameter, the definition of linear distance, linear velocity, and linear acceleration. So let us take this. So we know linear motion. Distance is the gap between any 2 points. Maybe there is a point A and a point B. The gap between these 2 points A and B, it's also called the distance. Now velocity is the rate of change of distance with time. Times the rate of change at which it's changed with respect to time is what's called velocity, which is v is equal to s over t. Now acceleration is the rate of change of velocity with time, meaning the velocity is being changed with time, is what we call acceleration under what linear motion. So now let's look at the angular motion parameter. Now under angular motion, angular distance is the gap from one point to another in a circular orbit, meaning the gap between 2 points. If peradventure an object is moving in a circle and it's moved from this point A to this point B, now the gap at which it creates, that is the gap here, is what we call the angular distance, psi. Let's remember. Now angular velocity is the rate of change of circular distance, which is angular distance, with what respect with time, in what it says circular orbit. It's just this circular motion that made angular motion different from linear motion. Now angular acceleration is the rate of change of angular velocity with time, where a is equal to what w, which w is angular velocity with time. Now we move to the derivation. We know linear velocity v is what distance all over time, and the linear acceleration a is what velocity all over time. Now for the angular velocity, w is what angular distance over time, and our a is angular velocity over time. We also know that our angular distance psi is simply the distance s with respect to r. Now making s such a formula, which is our distance, our s is equals to theta r. Now I'm asking, how do you get this theta? Now this is an object, point A and point B. An object moves from point A, let's call this point A, and this point B. It moves from point A to point B, and it's covered a distance. It's covered with angular distance with the linear distance. So s equals to theta over r. Now substituting, let's call this equation 1. Substituting this into our formula for velocity, we know v is equals to s all over t. Therefore our v is equals to, where our s is what? The psi of r all over t. Let's call this equation 2. If we call our angular velocity w is psi all over time, so we write v, where psi divided by t is at w, so it's become w r. So this is simply the relationship between linear velocity and angular velocity. And for the angular acceleration, we know linear acceleration a is simply v over t. So for angular acceleration, A equals to, where our V is what? WR. Come WR all over T. Let's call this equation 3, which is the derivation for angular velocity.